Okay, okay. So this is great. Um, before I start the session, um, in the previous session, there was someone have asked about um, like a big question that how the entire computer works or something like this, like how the CPU works or yeah, I mean, that was a big question. So I've just prepared this small illustration for today. And let me show you here. This is just a very basic illustration, okay? So basically, there is a module in the CPU. It's called the arithmetic and logical unit. It's just calculating with binary, which is a very basic system that have only zeros and ones. And this is all the numbers that the computer knows actually. And there is a very, very basic kind of operations, like if the two numbers are ones, then the result would be zero or one based on the operation. So I'm not going to talk about it, but it's so simple. So this is the calculator basically. It's called the ALU inside the CPU. So it can do a very basic logical operations, but it turns out that we can use it to do sum with a carry. We can do later if we add several additions, we can do multiplications. If we like reverse the number, we can do subtraction. If we do several subtractions, we can do division. So it's kind of hacky like this. But basically, this is the the calculator of the CPU. Then we come to the memory, and the memory is actually so simple. It's called the single cell is called a flip flop. It's like a let's say uh, it's like let's say a circuit that will output what is inside its memory all the time to the input again. So it's like memorizing its own output all the time. Uh, and this is happening based on a clock, and this is very important in the CPU. It's basically the heartbeat of the CPU. So it's like on each tick, it will do operations. All the circuits will do the operations on the tick. So if you want to change the memory, it will be changed on the tick. So for example, there is CPUs that are 2 gigahertz, 3 gigahertz, etc. So this 3 gigahertz is the clock inside the CPU. And old CPUs were like several megahertz. So it's like only million of operations per second. So this is what megahertz mean. It's how many operations per second, how many clock tick per second. And then there is what is called the control unit, which is just like a police officer in the street that is saying, if you want to do addition, then just take the output of this circuit. If you want subtraction, take the output of this session, of this circuit. So it's like all the circuits are connected together, but when you want several operations, certain operation, you will get the output that you want. And we can go further next sessions, but I just wanted to give a simple introduction, and we can go deeper in the next session when you have time. So this is basically just a very very basic illustration for what is inside the CPU. But if we have looked inside this, we can do all calculations and we can store in memory, and this is enough to do all the mathematical. Then every whatever operation we can imagine, we can turn into mathematical operation. So this is basically what's inside the CPU. And all of your programs will be stored in the memory. So the memory contains two things, the data and the program. So the data is like your images, your texts, your music. It's all data and it's converted to numbers. And the program is the instructions for this calculator. So which calculation do you want to do and which memory do you want to read or write? Basically, that's it. And of course, I'm overly simplifying things, but we can do in each session like a small step towards understanding computers. Okay, so let me start by showing you here. I've just shared my mobile phone here. This is an application it's called AnyDesk. I don't know if you know it. You can see the screen here. Yeah. Can you hear me, Ralph? Yeah. 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 Actually, we can accomplish this clock with several things, but there is actually a what is called crystals. Those crystals are a special material that when you give it a static current, it will resonate and it will give you what is called a clock. I can show you here. Basically, there is um, crystals used in CPU clock. Hmm. So this is it. It's a quartz crystals. And wherever you see this in a circuit, this, this is actually a quartz crystal that is oscillates. When you give it electricity, it will give you an oscillated output. And this is one of the ways that they are generating this clock, but there is lots of others. Like, let me just simplifying this. If you charge a capacitor and then discharge it fast enough, it will resonate and it will give you this clock. So this is basically what CPU clock is. It's a quartz crystals, a special material that will resonate, and you can read about it maybe on Wikipedia or whatever you want. Just want to show you some illustration for, yeah, this is it. So this is another one. Here we have a capacitor, and I don't know how to say this in English. So basically, this is a circuit that will resonate exactly as a crystal, quartz crystal. But quartz crystals are more stable. So this is some of the ways they are generating clock. But clocks will be something like this. It's like a sharp pulse. But for computers, we want square clocks. So this is just like we are digging deep into uh, electronics, and we don't have to. Yeah, it's just like this. This is how electricity goes, like 5 volts, 0 volts, 5 volts, 0 volts. So this is the clock, like this image here. So once we accomplish this kind of clock, we can use it inside the CPU to trigger all of the operations. And if you go step by step, you can build from the small building blocks that, as you said, it's transistors until you reach like a higher level of systems because it's like a Lego building blocks. You go step by step until reaching the CPU. But I maybe have to say that computers are theoretical uh, and it's not obligated to do them with electronics. There were a mechanical computer back in like 300 years ago. Mechanical computer, you can search for it, but it's huge. But it's performing the same operations. It do calculations, and this is you can see it. If you have a calculator, the calculator is basically a computer, especially if it has memory and variables, etc. But it it usually doesn't store programs, so this is why it's not autonomous in some way. So this kind of computers is called the Babbage machine. This is a mechanical computer. It's a very big one, and there's someone have did it yet in Lego parts. Uh, it's interesting to watch him, not to do this at home, because this is too complex. Yeah, and it requires basically lots of theoretical understanding of how computers works, but it's not basically hard, but the implementation is absolutely need lots of concentration to not ruin everything there. Okay. Yeah, yeah, yeah. Yeah, and also, Raf, I have to say logic gates are theoretical. The implementation, whether it's transistors or mechanical thing or whatever you want, is another thing. But basically, logic gates are just theoretical components, theoretical Boolean components or logical components. And that's it. This is all of what theoretical computers are built of. Anyway, okay. So I think enough of theory. Let's go now to games, as usual. Okay, where's my game? I don't know. Maybe. Okay, I just have to unlock my phone. Okay, here we go. Okay, so look what we have here. I have here my instructions, and here I have some input, and I have to produce some output. And if you look at this human as the CPU, it can only carry one item. Okay, so in if you carry one item, you can't basically do calculations without changing this item because you can't carry more items. So we have here this matrix and it's numbered. There is a number on each block here. So basically, this is what memory is. It's just a places to put numbers in. And if we don't want to say numbers, it's places to put data in. Okay? But those places have numbers. And to make it simple for programmers, we don't put our data in numbered slots. We put it in a named slots. Okay? So this is what, let me just show you here. Okay, I came across this level. Okay, so you can see here, I can just click any memory cell and I will say, this is my variable. And you can see here, I've just named this memory slot. So this is what variables are. You are going into the memory and just saying, okay, just please give me this slot. I want to put my numbers in. So for example, let me show you here. I just want to get this slot and I want to say this slot is, I want to name it A. I want to name this slot B. So this is what variables are. It's just a place in the memory and you give it a name. So if you just search the internet what variable is, So the simplest answer is it's a named storage location in computer memory. So why to use variable? Because we need memory. So whenever you want memory to memorize something, you have to go to the storage, and probably the best thing to do is to get a named location there. So you can use it time over time. Let me show you here. This is a very simpler illustration of what variables are. So you can think like it's just a box with a name. And inside this box, you can put one value. Okay, so this is basically the idea because like a, it's a variable, but the size is constant usually. So I can call this box score, and I can put number 10 inside the score. I maybe put 100, I maybe put 1000. It's okay, as long as I'm putting only one value. Okay, so this is what variables are. You can always think about variable as a box with a name, and you put a value in it. This value can be strings. String means text. You can put numbers, and there's types of numbers. You can put true or false values, which are just used for maybe conditions usually. And basically, basically, in lower level programming languages, you can just put those values, strings, numbers, and booleans. But in higher level programming languages, you can consider the variable is whatever you want. It's maybe an image, it's maybe a text file, it's maybe sometimes you may get a large object containing lots of things. So it's a box, still a box with one value, but this value can be complex. Okay? So I want to show you, uh, just getting out of code.org a little bit and show you the beautiful terminal. Just going to make the font bigger for you. Okay, okay. So let me see if that applied. Oh, that's very big. Okay, so I'm now here inside the Python terminal. And you don't have to look at anything, but I just want to show you a very basic programming instruction. I just want to print hello, run. Okay, so you can basically print anything. I can say print 1 plus 1. I can say print, for example, 2 times 5. So this is basically what print does. It's just printing things. But instead of printing the number directly, I can just store it into memory. And this memory can have any name. This is what is variable name. So let's call it the result that I want is 2 times 5. And then I can print result. So when I print result, it gives me 10. It's not give me the text of the text result, it gives me the value of the result. So I can just imagine that there is a box called result, and I am storing 2 times 5 inside this box. And when you want to print this, you will print the value. So you will print what is the content of this box. And this is different from writing this. Do you know what's the difference? Can anyone just spot the difference between this one and this one? Yeah. So, yeah. So here I'm just telling the programming language Python that this is a text. You have to treat it as a text. But here I'm just telling it it's a variable name. So give me its content. So here it will give me the content of the variable result, Here it's just give me a text called result, and it will not look at it. So I can just do whatever here, and it will print it there. So now if I just said, please print the value of the variable x, it will say name x is not defined. You didn't define a variable called x. Okay, let's define the variable called x. And here I'm assigning a value. I'm putting the value 1 inside the box that I have called it x. Then when I want to print x, it will tell me, okay, x is 1. X contains 1. Now, do you know variables in mathematics? I am sure you have worked with mathematics and you do some variables there. In math, if x is equal to 1, then x will be always 1 through the proof or whatever you are doing. But in programming, you can do x is 2, x is 3. So you are just changing the value. So if you print x now, so now you will have the latest value you put in x. Okay? So I can update the value of the variable and I can use this value again. So for example, I can say y is equal to x. So when I print y, I will get 3. This is the same content of x. But now, if I have changed x, if I said x is equal to 10, and then I want to print y, I want to hear from you. What do you expect the output to be? Yeah. So so if we change x to 10, what do you expect y to be? Yeah, Raf, I can hear you. So they said 10. Okay, let's see the output. Look at that. Okay? Yeah. We have two we have two separated boxes. The first box is X, the second box is Y. And when we do the assignment, this is not math. We are not saying that Y is equal to X. We are just assigning the value of X inside Y. So it's just like at this moment, we've just copied the value of X and store it again in Y, but they are totally separated. If I just go and said Y is equal to 100, X will not be affected. If I just said X is equal to 1999, Y is not affected. Okay? So they are totally separated, even though I said before X is equal to Y, but it's just an instruction, it's not a fact. And this is a big difference between mathematics and programming instructions. When you do programming instruction, you only execute the instruction at its time when you reach it. But it's not something that should be valid all the time like math. Okay? So now, for example, if I want to say z is equal to 1 plus x, so now z is equal to 1000. But if I have changed x to be 0, what do you expect z to be now? Okay, so z is still its value. Z is still 1000. Why? Because z is a different variable. It's a different box. X is 1 or 1000 or whatever. Z will not be affected unless we assign z to something related to x. So at this moment, z is equal to 1 plus x. But later we can't. We can't guarantee because even if x changed, this is not valid. Z now storing 1000. It's just storing 1000. It's not storing an equation, okay? So if I've asked you, what's the value of Z? You will not say it's 1 plus X. If I ask you what's the value of Z, you will say 1000. So why is that happening? Because 1 plus X, we will get the value, then we will store it in Z. So it's two operations. Do the calculation and then store in the memory or in the variable. So now again, if I just said x is equal to, I don't know, some arbitrary number to make it harder to do the mistake. What is the value of z? Yeah, yeah, exactly. So the variable will not be changed unless you assign a value to it, okay? So when I say z is equal to something, now the value will be changed. So if I say now z is equal to 1 plus 1, what do you expect z to be now? 2, right? But I can change this, and I can even, just let me change the variable z because it's sometimes confused with 2. I want to make a variable, and I will call my variable Raf, okay? So you will not confuse this with 2. So now Raf is 100 because it's always 100%. Okay, so if the variable Raf is 100, it's okay. I can print this variable. It's 100. And now look at that. This is different from mathematics. I can say Raf is equal to Raf plus 1. Do you expect this to be valid in programming? Yeah. What is going to happen here is first we are going to calculate Raf plus 1 and get the result, which is 101. And then we will store it again in the variable Raf. So when I do this, you will find that the value have been changed to 100 plus 1. And in this way, this is a very important type of instructions where you are updating the value by 1. So you are getting the old value, increase it by 1, and store it again in the same variable. Okay? So when you do this, you will have an increment in your variable. You are getting the value, increase it, and then store it again. And just to give you a hint, this calculation will happen in the CPU, but the storage will happen in the memory. Okay? So this is just fetched from the memory to the CPU, do the calculation, and write it again into the memory. Okay? So this is how variables works. And you can do whatever you want by those values later. You can just print it on the screen, or maybe you can use it to tell the robot how many steps to walk. Maybe you are sending a phone call, maybe you're doing some SMS. And let me show you some variables in real environment. What do you think? I will get you inside some of the top secret codes of of the company, and we'll show you how we do variables, okay? Okay. So, okay, and here we go. I have here some values here. Okay, look at that. Um, just focus on the assignments here, and let me just make this go away. And now you can see, look at that. I have a variable, just ignore everything else. I have a variable and it's equal to a value. Variable equal to a value. Variable equal to a value. So I have lots of variables. Do you want to know what are those variables? Okay. If you look from the computer perspective, they are just numbers. Okay. And in this case, they are text. It's a string. It's called string. So it's just text. But the interpretation of this, the effect of this is so different. The SPI, for example, is the security parameters for the SMS that is sent from the network to the mobile phone. And this is every bit in here is important. The KIC is something related to the security keys in your phone. The TAR variable, the content of it will affect what application in your SIM card will respond to the network. You can see this is infinite meanings for the variable, even if it's just text or number, or even if it's one bit. Imagine if there is one bit in a program will affect a plane, whether it's going to fly or landing. This is how it goes in computers. There's only one number, but will have a huge effect. So don't underestimate small things, okay? So it's number, okay, whatever. It's the string, okay, whatever. But what you are going to do with this number is so different. Look at that. We have here a basic calculation, and this is actually not the normal addition that you do with numbers. It's just like concatenating text with each other, because here I have text. So in this language, I'm using here Java language. In this language, you can like glue the text together to perform a longer text. And I can do something in Python the same way. Okay, I can have here a text, for example, hello, and another text, students, and another thing, text of Celsius, for example. And then I can print x plus y plus z, and you'll see here it's just get glued together. And because there is no spaces, I will add some spaces here. Okay, so you can see I'm getting the value of the variable x, which is hello. I'm getting the value of the variable y, which is students, etc. So now you get this text. Okay, and yeah, basically this is it. This is what variables are. It's just boxes of values. We can string several types. And usually we use these variables inside something that may change it, because if it will not be changed, it's not variable, it's constant, right? So basically it would be changed or it's a constant. And what one of the things that will change the variable is the user input. So for example, in Python, we can say x is the input of the user. I don't know what x is, but I want it to be the input of the user. So whatever you want to do here, I would say, for example, I don't know, Syria. So the value of x now is the text Syria, okay? And you can say here like Syria and Ghana, for example. So here I have a text, a plain text. Here I have variable. So it will extract the value from it and then will glue it with the other text. So you can see here Syria and Ghana. Okay. So this is one of the ways to assign a variable by getting the user input. Okay. Uh, Now let's look at that. What is print? You know, CPUs can't do print. CPUs can't do input. They can only do lower level things. So how are we able to do like a higher level thing? This input is actually lots of code, but it's just combined in a special word called input, for example. Printing value to the screen is a hard thing to the CPU. So there is lots of code already written by other programmers, and it's just combined and named print. And this is what functions are. So now let's jump to functions. And in functions, we have actually, instead of a box with a value, we have a box with instruction. Okay? So variables are boxes with data, while functions are boxes with instructions, with code. And you remember, there is data and code. This is what we can store. So the function is actually a mini program that can be used with other programs. Like for example, I can just write a function to get the user input and say hello, whatever name is. Okay. I can make some maybe harder functions. I maybe can encrypt the data and decrypt the data. You know, cryptography, where you just want to make the text ambiguous until you reach the destination, then you can unlock it. So you can make a function to encrypt the data. And whenever you want to encrypt the data, you can just call the function. So you can call the function instead of writing the code again and again. So look at the code, how it looks like if you just don't use functions. You'll have to repeat a lot, right? And I'm sure you have learned how to do the repeat command in code.org, but you can also do a better thing, that you can name a function. So whenever you want to draw a square, whenever you want to draw a square, just call the function draw square. And I will define draw square, which is just repeating 4 times, moving and turning right 4 times, okay? But whenever you want to draw square, just call the function. You don't have to write the instructions again. So you are building a building block. You just not building the program directly. You are building the building block. Then you are using those building blocks together to make your program. So your program will look like this. Okay. You are doing 4 times draw square. So you are drawing, for example, 4 squares. Okay. But the code of drawing square is just like hidden inside the draw square function. Okay? So you are hiding the code inside functions, and this is just like a static function. It will not change its behavior if you call it again, because it's not able to be tuned or changed. And this is what we are going to talk about next. So look at that. This is a function, a mini program. You can, you have actually 3 things. You have to define it. You have to define the function, and you have to call the function. And sometimes you can just declare the function, that I have a function, and this is the name of it, but I will not tell you what it's going to do right now. So this is called declaration. Okay, so here I am defining the function, and here I'm using the function. And you can use it like as much as you want. You don't have to repeat the code. You just call the function. Okay, so that's it. This is functions. Without functions, your whole code will be like a giant custom piece that's hard to change. If anything, what you want to change it, it's all connected together. You can't change it. But if you use functions, your code will look more like this. You have pieces that are, yeah, just the roof is built, the door is built alone, the window is built alone. So it's like it's not dependent on each other. You can prove the roof alone. You can change the roof. You can change the door. You don't have to change everything to change the door, right? So this is what's called modularity, and it's everywhere in engineering, and in software engineering it's not an exception. It's called modularity, and it's you can achieve it through functions. So this is again, if you want to draw square, you can write the code once and then put it in the box, which is called draw square. And when you want to draw a square with this size, with a special size, then we can use what is called parameters. So parameters are like tuning your function to do the thing, but with the different values. Okay. So for example, um, I would go here. Okay. And let me show you how I define a function in Python. I would say greeting. Okay. And greeting is just basically just saying hello, Raf. So whenever I want to say hello, Raf, I would just do greeting. Oops. Okay. Three, three E's. Yeah, this is a good example for an undefined name. Greeting is not defined because it's three E's. And here we can, yeah, this is not, there is no natural language processing in programming languages because they are deterministic. You can't just dependent on its understanding. Anyway, so whenever I want to say hello, Raf, I would call greeting. Okay, greeting, greeting. You can see when I do greeting, it's just like I have defined a new instruction to the programming language, to Python. I have defined a new function, okay? But it's a static. I can't change this. So I would define a new function called greeting a friend, let's say, and I will pass a parameter here. I will call it the name. And here I will say hello, and I will concatenate it with the name. And now look how I will change the behavior of this greeting. I will greet Raf first. It will say hello, Raf. But then I can say any name. Hello, Hussam. You can see it's just changing the behavior instead of writing a constant string all the time. Why is that happening? Because this value will be go into the variable name inside the function, and then it will apply hello name. Okay, so it's just like this. You have a definition here, you have parameters here, and this is the actual code that will be executed. Okay, and now what we can do more, we can just go here into the examples, and let me show you something I've just stored before. Yeah. So yeah, you can look at the function as a black box. You don't have to understand what's inside it, and you can just go and execute the content of it. Um, I wanted to do something that sounds more interesting to you than just printing and input the text from user. But for now, I will just do a very basic thing here. I will print a triangle, okay? And I will let you decide the side of the triangle. And to do a triangle, let me just show you what I mean by triangle first. It would be something like this. Oh, let me just make this bigger a little bit. How to do this bigger? I don't know. Okay, 1 second. Don't lose focus. Font and color. Yeah, do something bigger for the guys. Okay. Now I will do this. This is what I mean by triangle. Okay, so to do this, I will loop several times, and in each time I will print asterisk, same as the number of the line. So in the first line I'll print 1, the second line I'll print 2, the third line I'll print 3. So this is just a basic program usually. So here's what I'm gonna do here. You don't have to understand the code right now. But I just want to show you how it goes. Chain range, size again. Just do this, and the end would be nothing, I think, and then print line. Okay, so this is a function. This is the definition of the function. This is the parameters. This is the body of the function. So this is the logic. It's looping, just looping. And now you have a new instruction called print triangle. And you have to give it the size. I can give it like this. This is called named parameter. Or I can give it like this without naming the parameter. So a triangle of size 1 is this, but a triangle of size 10, oops, triangle of size 5, oh, okay, no, we have to change the function. And to change the function, we have to make this like, okay, mm-hmm. 1 second. Preferences, just make the font smaller so you can read it. Anyone has spotted the error? Okay, so this is it. Okay, this is Python. Okay, ready. And we will define the function again. Let's print triangle again, size 1, size 2, size 3. Okay, great. Now let's have size 5, size 10. So you can see I have defined a new function. I have defined a new instruction to the programming language Python here, especially in my program. So if you have my a definition of the function, you can always print triangle whenever you want. If you want to do it inside your program, you just copy my function, and then you can use it whenever you want. So now I can do more code and include this function inside it. So I can do print triangle inside this for loop. So you see several triangles. You can see, okay? So this is it. I want to make it simple, no complex examples, but uh, that's it basically. You're just calling the function to do things for you. And if you have any questions, yeah. So let's search this for on the internet first because terminologies differs. And let's say what a pure function is. So I don't know, maybe searching in JavaScript or in Python. So what a pure function is. Consistently produces the same output for the same input, and it causes no side effects outside its scope. Okay, so um, Imagine, imagine that you have a black box and it has the ability to give input and to get output of it. It will always produce the result, the same result, if you give it the same output. It's like a calculator, for example. If you give A and B, the same A and B, addition is always the same. And when you do this, nothing else would be changed. So, for example, you will not consume memory. You will not consume like um, uh, changing other variables. You are just giving me the result. So let me show you what a pure function can be like this. Let's say this. I'm just calling this pure function for my friend. Okay. And I will give it x and y. And it always will return a value. I don't care to print something. It will not printing something. It will not uh, changing anything in the user output. It's just giving me the result, okay? So for example, it will always give me x and y times 2, okay? So whenever I do this and give like 2 and 5, it will always give me 12. Okay, let's try 10 and 10, 2 and 10. It will give me this number. Okay, look, it's always returning the same value. Okay, now how it looks like if it's not a pure function. Okay, now let's look at something that is not a pure function. Now I will do thing, I will define a list and I will call it the list of callers. Okay, the list of callers, and it will start as an empty list. This is how Python defines lists. And I will define the unpure function. And again, this is not an exact word to use. I'm just doing anything here. You can name it whatever you want, okay? So let me just break language here. I put 0 here. I will put P here, maybe put 1 here. Anyway, so this is unpure function, okay? You can name it whatever you want. And this function, I will just give it a name and it will just print something here, hello, and a name, but it will always add the name to the list here. Okay, now look what happened. If I call unpure function and I will say, okay, just greet Mostafa, it will say hello Mostafa. If I give it hello Joel, it will say hello Joel. It will say hello Raf. Every time I call it hello Raf, it will show me the same output. But first, this output is a print on the screen, and I don't want it to interact with the external environment. The second thing is that every time I call that function, it was changing the list. So now if I just look at the list, you will find every name I have called before. And if I have called this function again, and let's say now I will greet like George, you will find that the list of callers has changed. So the environment is changing because of calling this function. It's changing the environment. It's not just calculating and giving me the result. And this is why it's not pure. If you call it several times, it will change the environment. And some changes can be like distracting or do some damage for your memory. I don't know. For example, I can show you something dangerous. Look here. I have a certain amount of RAM here. You can see here. And now I will just make a list and I will make it big, so it's a list of range of numbers like I don't know, 10 millions maybe. Okay, and I will append this amount of elements each time the function is called. So here, a dangerous function, and each time I will call this, well, let's first define a list, and every time I call this dangerous, I know I have typos here. It will append a list of range. Okay, this is a big number. When you define the function, there is nothing happened because you didn't call it yet. But look at this. I hope you can see what will happen. Every time you will call this function, oh, what a name list range is not defined. Oh, really? Oh, sorry. 1 second. Let me just append. What's that? Strange. Yeah, yeah. This is what I want to do. Okay. Let's try. Okay. Now I'm calling the function, and you can see it's hanging a little bit because it's appending something. You can see the spike here. You can see what happens to my memory. It's rising. Now the function is changing something, it's storing things. And pure functions never do this. If I have called this function again, my computer might get 100% of RAM memory and I will not be able to continue the session. So now I can show you what will happen if I've exited my program. I will exit the program and when I exit the program, it will take time because it's trying to freeing the memory. And I now get out of the terminal. You can see what happened to the memory. Yeah. So it's now freeing what was allocated. This is what the term is, allocating memory. So when I define a variable, I want to store something to the list, it will allocate a memory inside my RAM because there where the programs goes and we're storing this data in a non-permanent way. Okay, this is not the hard disk, the permanent memory. No, this is the working memory, the RAM memory. Okay, so it's allocating place in the memory, put the data there, and when you don't want to use this anymore, the operating system or sometimes the programming language interpreter will free the memory. So there is someone who is responsible to allocate the memory, free the memory, and this is in a higher level languages. But in lower level languages, you are the responsible for doing this. And let me tell you that lots of hacking in the past years happening because of memory management. It's like you are storing something in the memory and you don't remove it after you are exiting the program or doing something else. And then there's another process can get this memory and read it. And this process might be some virus or something that will get the data, etc. So it's always happening on the lower level of memory management. Anyway, so this is about pure functions. Any other question, Ralph? Yes. Yeah, Raf. Yes, Raf. Um, if I have heard correctly, you are saying what makes the function void? Yeah, yeah, this is basically in some languages like C++ plus plus and C. This is what you are saying? Okay, so let's write a C program. Let's call it hello.c, and I'll just write a void main. This is what you are talking about? Okay, and then maybe include um, standard IO with H. So you have encountered this before? Okay. No, guys. And then I will compile this, and then I will have the a.output. And when I execute it, it will give me hello, guys. Okay. So what is void here? Void is meaning this function will not return anything. Let's define here a function called addition or add, and I want it to get integer a and integer b, and I want it to return a plus b. So I want this just to say this is very, very basic, and it will say the result of 5 plus 7 is, okay, let's put this here, and it's add A and B. So here I'm defining a function. Here I'm calling the function, and this function is returning an integer. I know it should return an integer. So when I go and compile this code, okay, I don't have A and B, sorry. So let's define A and B here, but I will change the names just to show you. This is number one is equal to 5, and this is number two is equal to 7. And I will put here different names because I can do this. Because this is number one and number two. So let's read the code again. This is the function definition, and this is the function call. And I'm getting the result of this function, which is a plus b, and print it here. So, okay, again, this is hello, this is a dot out. You can see the result of 5 plus 7 is 12. This function is returning an integer. But if the function is not returning anything, like this one, for example, read, and here we'll have, I don't know, name, and you will say printf hello, and we'll have here the name, and I'll say, okay, see here, printf greet, no printf here. I don't want to use printf, I just use greet everyone. Okay, now let's try it. Compile, run, and here I'm greeting hello everyone. Now look at the code. I have a function that will not return a value. It has no result. It's just doing things. It's printing to the screen. It's drawing a rectangle. It's like doing something in the external world. So I don't need anything from it as a result. But this function, it's not doing anything to the external world. I want the result of this calculation. And calculation sometimes goes like too complex, as that I really need a function here. For example, I can do some cryptography, for example, for some number, and here I will return some complex, I don't know, gibberish mathematical functions here, and it will work and will give me the result. So return is giving the result to the caller. The one who calls the function will have this result. But void functions are functions that don't have a result to give you. It's like you just tell me to go and close the door. You didn't ask me a question whether there is someone outside or not. If you ask me a question, I have to return the value to you. I have to return the answer to you. And maybe we've missed this when we talked about functions, that function return a result. And maybe this is, like something missed. So thank you for the question. So this is a void function. It will not return a value. And this is not void function. It will return certain value. And here we have type integer. Okay. Yeah. Okay. If it's a local variable, it will be destroyed once you exited the function. So if you want to do anything with this variable, you have to store it again in something permanent. So for example, I have here a variable inside the function. I'll just make a function, and here I will call the variable x, and we'll store number 100 in here, and we'll maybe do some function here, x plus 50, and print x plus y anyway. And whenever you call this foo, you will get this number. But if you just print I want x, it will say x is not defined. Okay, because it only defined inside the scope, and this is why it's local. But you can define a global variable. I'll open a new terminal here. You can define a global variable. You can say x is equal to 1. So inside function foo, you can access this global x, and you can print x, or you can modify x here. I will say x is equal to x plus 1. And this is a great example for non-pure functions, because whenever I call foo, the x would be changed. You can see I'm calling foo, and x is changing. So let's see how x, here's x, here's x. But when I called foo, x is changing. So this is global variable x that is permanent outside of the function. But if it's a local variable, it must be destroyed when you get out of the function. So in this example, x and y only exist inside this scope. Yeah, you are all most welcome.